Okay, continuing on with SPI 9.9, we're still talking about arranging the elements. This time we're going to talk about groups and families. Okay, a periodic table also has a group or a family. Those two words are interchangeable. Okay, sometimes you'll see them as groups, sometimes you'll see them as families. Okay, so what you need to know is when we're talking about a family on the periodic chart, it is talking about a column, and columns go up and down. You have a total of 18 families. Okay, so I want you to draw you an arrow beside the graphic. Okay, and you can see I circled here group 1, group 2, group 3, all the way it goes to group 18. Okay, so how are these families then? Why are they together on the periodic table? So let's look at that. Okay, the first reason is because they are based on the number of valence electrons. Now, this goes back to our Bohr diagram. In just a second, I'm going to give you a visual of what we're talking about, but first I'll give you a definition. Valence electrons is the number of electrons that's found in the outermost shell. Okay, so when we done our Bohr diagram, it's how many electrons was found in the very last shell that you put electrons in. Okay, so let's look at some examples here. Okay, so here's group 1, here's group 2, here's group 3 through 12. That's the transition metals. We will not talk about the Bohr diagrams on those because they don't always follow the same rules as some of the others we're looking at. Okay, group 13, group 14, 15, 16, 17, and group 18, or family 18. Okay, so let's look at group 1 now. Alright, do you see that I circled each one of these valence electrons, the outermost shell's electron? Okay, each one of those in group 1 only has one valence electron. Okay, let's look at 2. Guess how many valence electrons those had? 2. Okay, group 3. Now, group 13 only has 3 valence electrons. Okay, the rule is when you get to groups 13 through 18, you subtract 10 from the group number, and that will give you the number of valence electrons. Okay, so you can see at group 13, aluminum atomic number 13 also has 3 on the valence shell. Okay, so here is group or family 16, and you can see on the oxygen that there is 6, and I've circled them if you'll count that, there is 6 outer electrons. Okay, same thing goes for the element right below it. Okay, alright, so one last look. Number these groups or families. Okay, and the only difference, and I've highlighted, marked through it, is helium. It is over here. You'll find out because of its characteristics why it's with it over there in family 18 or group 18. But it only has 2 electrons, so it can't have 8 in the outer shell. Okay, you know in science there's always a rule, an exception to the rule. Well, there's your exception. Okay, but I hope that you can see that the group number or family number is equal to the number of valence electrons. And again, valence electrons is the number of electrons in the outermost shell.